So here is the pre-lab for your very first lab of the year. I know you're so excited. I am. So the first pre-lab question is talking about iron instead of silver, but I think y'all can relate. You got a piece of iron, has a mass of 85.65 grams, burned in air. The mass of the iron oxide produced, I'm not having a pen anymore, produced was 118.37 grams. So use the molar mass of iron to convert the mass of iron used into moles. So the mass of iron that we used was 85.65 grams. And the molar mass of iron is 55.85 grams per mole. So to convert this into moles, simply take that 55.85 grams per every 1 mole. Your grams are gone. And this works out to 1.534 moles. For some reason, this isn't wanting to write in a way that is legible, so hopefully you were able to hear what I said, because if I have to write this slow, I think I'm going to go insane. Which, according to the law of conservation of mass, what's the mass of oxygen that reacted with the iron? Well, if we had 85.65 grams of pure iron and we produced 118.37 grams of the iron oxide, well, to figure out how much oxygen we use, we just take the mass of the iron oxide. Wow, this is just like painfully slow. I'm so sorry. And we plug that in and you get 32.72 grams of the oxygen. And so calculate the number of moles of oxygen in the product. Well, you just take this 32.72 grams and do the exact same thing you did up here, except that the molar mass of oxygen is 16 grams per mole. So we take that 32.72 grams. Wow, I don't know why this thing is so laggy. I updated to Microsoft Office 2011. You think it'd be better. So this 16 grams. Wow, this is awful. We can just laugh through it together. To every 1 mole. And as I'm sure all of you already have worked out, this is 2.045, and I'm not even going to bother writing the word moles. Moles of oxygen, so about 2 moles of oxygen. So going on to the fourth question, use the ratio between the number of moles of iron and oxygen to calculate the empirical formula. Well, we know that, wow, am I going to have to go, that's going to get old. We know that iron was 1.53 moles, and we knew that oxygen was 2.045 moles. It was 534 moles to keep our sig figs going here. And so to get this into a simplest ratio, just take both numbers and divide it by whichever one was the smallest. So in this case, it was 1.534. And of course, this works out to 1. And this works out to 1.34, or about 1 1/3. And so since this is about 1 1/3, this is about 1, to get rid of that third, multiply both of them by 3, because we don't want to have, we can't have fractions. You can't have FeO 1 1/3. So multiply both of these by 3 and you get that the ratio of iron to oxygen is 3:4. So the empirical formula is Fe3O, or which We know that this isn't actually possible because if it were, then that's saying that oxygen is having an oxidation number of -3, which oxygen can't do. Oxygen can only do -2, -1, or +2. And so what this actually is a mixture of regular iron 2 oxide and iron 3 oxide, known as magnetite. And everybody knows magnetite because you have fun playing with it as a kid. So that actually is all of the pre-lab. Then all you guys need to do is read through the lab procedure itself and copy down your tables and be ready to do your lab tomorrow. See y'all then.